Okay, some more question we'll do here, then we'll move to next semiconductors. $20 minutes. The approximate time interval T2 minus T1 between T2 when 2/3 of it had decayed and T1 when 1/3 of it decayed. Is 30 days, 50 days, 60 days, 15 days. Solve this. E to power minus lambda t. This is a formula, right? So we have n1 equals to 1/3 and not and not equals to e to power minus lambda t. Only 1, 3. This is T2, right? This is a formula. And this is T2. Talking about T2 only. 1/3 e to power minus lambda T2. And next one we have 2/3. N2 equals to 2/3 and not 2/3 and not equals to and not by e to power minus lambda T2 T1. E to power minus lambda T1 equals to 2/3. Divide this both equation. You get 1/2 equals to e to power minus lambda T2 minus T1 Then if I send this E that side, it will be okay. ln of 2 by lambda. So T1 by 2, which is $50. No, this question we have solved, I think so. Okay, let's try. A nucleus X Mn emits one alpha particle, two beta particle. The resulting nuclei, so nucleus is it's very easy. Come on, solve it fast. Z equals to M minus 6, N minus 4, and N see when X emits one alpha particle. Okay, so atomic mass is decreased by 4, 2 electrons. That's right. And atomic number by 2. So our new nuclei will be Z equals to M minus 4 and minus 2. Okay. But it has 2 beta particles. So it is increased by 2. This is increased by 2. So Z equals to M minus 4 N. So option C. One alpha particle means atomic mass decreased by 4. And atomic number by 2. Then 2 beta particle here we have. So atomic number, this atomic number increase by 2. Okay. Any doubt in this topic? Shall we go to semiconductor? Before going to these questions, let's recall everything. Difference between conductor, semi, and insu. What are the difference between this one? First, let's start with range. Range 10 to power -6 to 10 to power -8 ohm meter. This one 10 to power 5 to 10 to power 0. 10 to power 7 to 10 to power 16. So this all have, and semiconductor and insulator have higher. No conductivity. 10 to power 6 to 10 to power 8. Reverse of this one. 10 to power -5 to 10 to power 0. 10 to power 7 -7 to 10 to power -16. Temperature coefficient. It will be positive, negative, negative. How does flow of current work? Due to free electrons, due to electrons and holes, and no current. And a gap or energy band, there is overlap. Here, some forbidden gap is less, about 1 electron volt. This is 6 electron volt. Forbidden gap is bigger. Here it is 0 electron volt. This range is 1 to 3 electron volt. Here it's more than 6 electron volt. If you go for semiconductor, you know examples, right? GE range is 0.67. Silicon 1.14. Here, so many: wood, plastic, rubber, mica, diamond, whatever. Here, carbon, Ga, AS, etc. So many. Generally, we are using this too. N-type. So in N-type semiconductor, silicon or germanium is doped. Pentavalent. These things you know, right? Electrons, number of electrons are more than number of holes. Electrons are majority, minority are holes. These are things you should remember. It will help you for like some questions solving. In p-type, it is doped with, this is doped with trivalent, like B, Al, etc. In holes are minority carrier. Sorry, majority carrier. In n-type, holes are minority carrier. Now let's go with some formulas and gates and diodes. Junction diode. What is PN junction? P-type semiconductor joined to n-type. What is PN junction? They use as DC to AC convert. It is inverter. As a Zener diode. This is used for voltage regulation. This one forward bias, reverse bias, these are important. What is forward bias? And reverse bias. In short, like positive terminal connect to P side and negative terminal to N side in forward bias condition. In reverse, opposite. Potential barrier. Potential difference between depletion layer. A region. Potential difference in depletion region. That is, what happens in this point? The region, either it moves to junction free side from charge carrier, and another VB will be silicon. Okay, it just move either side, this side or other side. It's just a depletion layer. So you know value of this voltage, silicon plus 7V, germanium plus 3V. So this depletion region is about 10 to the power minus 6 meter. transistor. 3-terminal of semiconductor NPN PNP. So configuration CE, CC, okay. Emitter, base, collector. These all things you remember, right? Uses of transistor. It's used for switch, oscillation, oscillator. Switch in the sense what? It will just transistor in cutoff region. That is a switch. Or saturated. Oscillator. So frequency, that is V equals to 1 by 2 pi under root LC. Amplifier. Amplifier. Increasing what? Amplitude of signal. Not just any signal, input signal. PN junction diode as a rectifier. How it would be used? It converts AC to DC. Rectifier converts AC to DC. So half wave rectifier, when what happens? Simple, it's very simple. Like PN junction diode rectifies half of the signal. That's it. So it is half wave rectifier. Efficiency percentage equals to P out by P in into 100, which is for standard 40.6 divided by 1 plus RF by load resistor RL. So form factor IRMS IDC 5/2, which is 1.57. So if I ask full wave, ask about full wave, it's simple. It rectifies both half, not just this first half. It rectifies both half. And the forward bias and reverse bias. For this, we need reverse graph. ठीक है, these are points you know, right? Knee voltage, this is breakdown, reverse current, forward current, logic gates. Or gate addition, and so gates, you know, easy, right? Not drawing here. Or gate and not or bar, nor and this was a combination of these three. Let's do some question with this. As we wrote this one, common emitter has highest input resistance. No, common collector has highest input resistance and common emitter. 1 second, you want to go? These are points you know, right? You should remember those points. Better do, let's do some question. In the reading of ammeter, silicon diode is given in circuit. Zero, 15 milliampere, 11.5 milliampere, 13.5 milliampere. Solve this, come on fast. This is forward bias or reverse bias? No answer. Okay, I'll solve. Forward bias. So voltage will be 0.7 voltage. So current I equals to V minus delta V by R. So 3 minus 0.7 divided by 200, which is 11. One zero 10 R R. It is LED Y. This is a 6 voltage. See, correct the Boolean operation represented in the diagram. So when the correct this Boolean operation, it is also asking 19. This AND B or C NAND T NOR. See, from this side 1, this side 1, sorry, 0, 0 will go, it will give you know how to solve. LED will glow, right? Because it's complete circuit. Will it? When it has high voltage. The truth table of A, B, and Y can be possibly 0, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0. This is for A dot B bar, which is NAND gate. The temperature dependency of resistance of copper and undoped silicon in temperature range is best described by options are increase for CU, exponential decrease of SI. Linear decrease for CU, linear decrease for SI, and linear increase for CU and exponential increase of SI. Fourth one, both linear. So if you see the graph for metals and semiconductor, metal graphs like this, semiconductor is this way.
Sir,
Yes,
option yes, sir.
option. Yes, it gives option. It is exponential. Very good. Another question was asked in IV characteristics of LED. So there are 4 options here. Three, 4. 3, 4, B, C, D, and these are R, Y, G, B. Same here, R, G, Y, R, Y, G, B. This is not exactly at 0, it is at this point. So, yeah, somebody wrote, yes, correct. Because for the same current, this all are flowing this way. Right, same voltage. We need higher value of voltage here. They are like getting R, Y, G, B. So yes, A option is correct.
Sir,
Yes,
what is mean by GB, sir? RY.
these are the colors.
Okay, okay, sir. Sir, can you please explain once again?
Okay, see what they are saying. IV characteristics of LED. Okay, we want for the same I here, V here. For the same current value, we are getting higher value of voltage with high frequencies. High frequency. So first is the only option here. This all are not a correct option out of this four. Right. So with this small value of current, small value of current, we're getting higher value of voltage. It's increasing. Understood?
Sir, V is directly proportional to I, na sir?
Yes.
Okay, sir.
V is proportional to I by V is proportional to R. V by I. So it is inverse with R. That is okay. That's not required here. But here, what is the main thing here? We need with the small amount of current, we need higher value of voltage. So higher the value of the voltage for higher frequency. Here R, Y, G, B, higher frequency. So there is one network given here. Let me identify this network. You guys understand because I'm not able to draw properly. Y input A and B. Is this OR gate, NOR gate, NOT gate, AND gate? Find out.
Nor?
Yes. Because this output, let's take Y1 and let's take Y2, let's take Y3. Not required Y3, but okay. So Y1 will be double input for Y2. And Y2 will be input for Y3. That will be your answer. You got NOR? Just a second, let me check. Where is that question? Option B, there is NOR. Let's do one more question. Do you want me to solve or you're okay with this? Yes?
Okay, sir.
Okay. Let's do one transistor numerical so that we can cover every part. And NPN transistor is used in common emitter configuration. as an amplifier with 1 kilo ohm load resistance. Signal voltage of 10 millivolt is applied across base emitter. Okay. Last to last year question. This produce 3 milliampere change in collector current and 15 microampere in base current. So find out input resistance of amplifier. Or let's not just this much, input resistance and voltage gain. Okay. Input resistance as well as voltage gain. Fine. Okay, let me solve because we don't have much time here. You have maths class, I think so. So the things 1 kilo ohm, 10 milliamp. Okay, okay. So delta VI equals to 10 into 10 to power minus 3 voltage. Delta IC 3 into 10 to power minus 3 amp. IB 15 into 10 to power minus 6. That's it. We don't need anything else. Ri equals to delta Vi by delta IB. So 10 into 10 to power minus, 3 divided by 15 into 10 to power minus 6, which is 0.67 kilo ohm plus, right? Yeah. 15.3, yeah, correct. Two by 3, which is 6666. Voltage gain delta IC by delta IB into R naught by Ri. R naught or RL, load resistance. What was this value? I see 320 power 3. This is 15 into 10 to power minus 6 into 1000 divided by 0.67 K. That means 670. 6. What are the options? Let's choose from option 0.67. We have only 2. In options, we have 0.33 kilo ohm and 1.5. It is not possible. 0.67 kilo ohm and 200. This is possible. 0.67 kilo ohm and 300. So this is only possible. So if we are getting 250, more than 250, then choose for third option. If you're getting near to 200, then choose for first option. What are we getting here? 20.
Sir, second option.
Are we getting 200?
Yeah, approximately.
Divided by 67 if we do. $66. No, it's somewhat.
Sir, 67, 20,000 by 67, no, sir?
Yeah.
If take numerator 10 to the power of minus 3. Then
It's
67 is a 201, sir.
It's almost 280, 250, more than 250 it will be. Seven will go. 9. Yeah. And some more digit, let it be. No need to calculate. If you get 2 digit nearby, okay, leave it. Don't waste time in that. Choose this one, 300. Let me check again. Calculator, 20,000 divided by 67. Yes, it's 29 something. So let it be. We'll choose option C. Okay. Okay, guys. See you tomorrow. I have another class to join.